Welcome to this calculation video where we're going to take information from a CT and a PT and calculate the watts or the total power in a circuit. So here's my circuit. I've got a 400 amp, 240 volt, 0.9 lagging circuit. So it's currently drawing, well, we don't know. That's its rated values. 400 amps, 240 volts. We just know it's a 0.9 power factor. So let's say on here we get a PT or a potential transformer. Right? And let's say this potential transformer is currently reading 118 volts. Awesome. We also have a current transformer or a CT, and let's say our CT is currently reading 3.92 amps. Well, the thing to remember here is it's all about ratios with CTs and with PTs. So with a potential transformer, our rated secondary is always 120 volts. So if we're looking at this, we would say, okay, well, 240 volts to 120 volts is a 2-to-1 ratio. So in this case, I would take my 118 volts that I'm actually reading, multiply it by my ratio. So I go 118 times 2, which means that I actually have 236 volts. That would be the rated voltage, or not, sorry, not the rated voltage. That would be the actual source voltage at this point. I do the exact same thing with my CT, my current transformer. So we would say here, okay, 400 amps. Now, current transformers have a 5 amp rated secondary. So it'd be 400 to 5 would be that ratio, which we can break down to an 80 to 1 ratio. Now again, I take my actual current flowing on the secondary, 3.92, multiply it by my ratio, which in this case is 80, and that is going to give me my true flowing current on the primary, which in this case gives us 313.6 amps. So that's just a quick breakdown of the potential transformer calculation and the current transformer calculation. A couple other videos will pop up here at the end to go to a PT video and a CT video just to get a little bit more in depth into each of those. But now, I said we were going to calculate my true power or my watts in this circuit. Well, that's just the calculation that we always do, right? We are going to take our voltage times our current, and in this case there is a power factor, so we are going to multiply by our power factor because that is how I would calculate true power. So 236 in this case I would get about 66.6 kilowatts would be my true power for the circuit. So very, very quickly there, just going through a calculation that you would do for a PT and a CT. Now keeping in mind this on a watt meter would be done internally. So it would take the in-phase values to figure out your true watts. In this case, if we just multiplied 236 by 313, that would actually just be our VA. In this case, we knew our power factor is how we were able to get to those watts. So I hope that helps a bit. Thank you so much for watching. Like I mentioned, make sure you check out these 2 other videos and make sure you also have yourself a great day. Thanks.